Hello, this is Simply Life. This time, I would like to delve deeper into the theme that the world is made of information, based on what has been revealed through experimental verification of quantum entanglement. To be honest, I've studied and shared about quantum entanglement many times, but I was completely lacking in my studies. Hey, kabadati! It might sound like an extremely far-fetched theme, but the idea is that everything is information. It seems that the research on quantum entanglement, which won the 2022 Nobel Prize in Physics, has become common knowledge in the quantum world. Until now, I couldn't comprehend the impact of the experimental verification of quantum entanglement at all. It's truly astonishing. Even after learning about it, I still can't grasp it intuitively. Many of you might be wondering, what exactly is quantum entanglement in the first place? Knowing what this research has proven could completely change your perspective on the world. The reality we take for granted as real might actually be nothing more than an accumulation of information. However, to truly understand this meaning, we first need to grasp the basics of quantum mechanics. So, without further ado, let's get straight to the conclusion. The experimental proof of quantum entanglement has refuted the concept of local realism, which is the idea that objects exist independently in a specific location. Does that mean objects don't exist? What is local realism? I received 2 question marks. Thank you. From here, I will explain everything clearly and in order, so please stay with me. In this video, I will discuss 4 points. 1. Quantum entanglement denies reality. 2. Reality is an illusion created by the brain. 3. The real world is a hologram. And 4. The world is made of information. Let's get started. Point 1. Quantum entanglement denies reality. In December 2024, NHK aired a special program titled Quantum Entanglement, Einstein's Last Riddle. Just the fact that Hikaru Utada narrated a program about quantum entanglement was exciting, but at the same time, I also felt the growing attention towards quantum mechanics. The complex discussions surrounding quantum entanglement. Using analogies and creative explanations, the program made it easier to understand. I believe it's still available on NHK On Demand, so if you're interested, please check it out. Now from here, I'd like to briefly review what quantum mechanics is, and then move on to the main topic. What we learned in high school physics was called Newtonian mechanics. This is the physics that describes the motion of visible objects, such as a ball flying in a parabolic trajectory when thrown. This is known as classical physics. However, when we delve into the more microscopic world, at the level of atoms and electrons, Newtonian mechanics no longer applies. Quantum mechanics, which is a part of modern physics, seeks to unravel the physical laws governing this extremely small world. Now, let's take a closer look at the concept of local realism, which is crucial when discussing quantum entanglement. Although it may sound complicated, rest assured that it becomes clearer when broken down into locality and realism. Let's start with locality. I will simplify the explanation for you. Imagine 2 distant points. For example, Hiroshima and London. Now, suppose an experiment is being conducted in Hiroshima. Could you imagine that due to some phenomenon caused by the actions of a person in London, the results of the experiment in Hiroshima change instantaneously? That is, at a speed exceeding the speed of light, which is considered the highest speed in this universe. According to the theories built up by traditional classical physics, such a thing should not happen, and in fact, no such instantaneous effects have been observed in physical experiments so far. This property, where physical effects can only propagate at speeds below the speed of light, is called locality. Next, let's talk about reality. What about the physical quantities we encounter in everyday life, such as the position or velocity of a ball? It is common to think that they have definite values at every moment. For example, let's consider the act of measuring height. We think that whether we measure it or not, the height is already determined. Intuitively, don't we think of measurement as an act to find out a value that is already set? This perspective, where physical quantities have definite values regardless of measurement, is called realism. This way of thinking seems obvious in the world we experience every day, doesn't it? Yes. To summarize locality and realism here, locality means that physical effects can only propagate at speeds below the speed of light. and realism means that physical quantities have definite values at any given moment. Assuming both of these simultaneously is called local realism. Local realism aligns with the reality we intuitively consider both in the world of physics and in our common sense. It was naturally considered correct. Therefore, physicists naturally assumed that local realism would also apply to the microscopic world of quantum mechanics. However, it was proven through experiments on quantum entanglement that local realism does not hold in the quantum world. Quantum entanglement refers to a phenomenon where two particles, such as electrons or photons, are, no matter how far apart they are, instantly correlated by measurement. To put it in a very simple analogy, imagine placing two entangled electrons each in a separate box. Alice takes one to Hiroshima and Bob takes the other to London. When they measure them, if Alice measures the spin of her electron as up in Hiroshima, then in London, Bob's electron spin will be definitely down. In other words, the measurement result in Hiroshima instantaneously affects the measurement result in London faster than the speed of light. This has been demonstrated through experiments, showing that locality does not hold. Additionally, the physical quantities of quantum systems, such as the spin of electrons used in the earlier experiment with Alice and Bob, are determined probabilistically through measurement. To make this easier to understand, let's consider using a die covered with a cloth. At this moment, we cannot see which face of the die is facing up. In this situation, we assume that the face on top of the die is already determined before we uncover the cloth. However, in the world of quantum mechanics, this way of thinking does not apply. In the microscopic world, the face of the die is not determined until the cloth is lifted, and lifting the cloth is equivalent to the moment of measurement, where it probabilistically becomes one of the faces from 1 to 6. The peculiar property of quantum physical quantities is that they are determined probabilistically through measurement. And it is this probabilistic prediction that is the essence of the field of quantum mechanics. In other words, it is understood that in the quantum world, neither locality nor realism holds true. In 1964, physicist John Bell derived a mathematical inequality known as Bell's inequality, which states that if local realism were truly correct, the probability would not exceed this condition. Then, Alain Aspect, John Clauser, and Anton Zeilinger demonstrated through experiments that Bell's inequality is violated, meaning that they proved that local realism does not hold, and they were awarded the Nobel Prize in Physics in 2022. In other words, the conclusion was reached that neither locality, which states that physical effects can only propagate at subluminal speeds, nor realism, which posits that physical quantities are determined before measurement, holds true. The implications of this experiment are both simple and shocking. In the quantum world, the previously unquestioned belief in local realism has been refuted, proving that measurements at distant locations can instantaneously correlate with each other, and that physical quantities are not determined before measurement. This means that what we usually consider to be physical reality operates under completely different rules at the quantum level. The point is that reality is an illusion created by the brain, and the experimental verification of quantum entanglement has experimentally refuted the local realism that suggests there is something there. This forces us to confront the fundamental question of what the essence of the world is, only. Dr. Zeilinger, who was awarded the Nobel Prize in Physics in 2022, is a leading figure in quantum information research and an author. In his work on the future of quantum teleportation, he states the following. The same can be said about our teleportation experiment. In this experiment, the concept of information was also crucial. The quantum state being teleported is nothing other than information itself. Omitted. Here, I would like to touch on something very important. The concepts of reality and information cannot be separated from each other. Omitted. Why couldn't Einstein refrain from criticizing quantum mechanics? Why? The reason why he called quantum entanglement spooky is now becoming clear. The reality based on facts, as he saw it, possesses essential characteristics independent of us. This perspective where reality and information are separated, seems indefensible in quantum physics. To quote, "A quantum is the smallest unit of energy that makes up the matter visible to our eyes," and according to Dr. Zeilinger, a quantum is information, and information cannot be separated from the concept of reality. From this, it follows that what we recognize as matter is essentially a collection of information. Moreover, when we think about it, the reality we perceive is merely the result of information processing, and the truth that the world is increasingly made up of information becomes more convincing. We usually think that the world in front of us exists as it is. However, in reality, we are merely seeing the world as a result of the information processed by our brains. In other words, the scenery you are seeing now, the sounds you are hearing, the sensations you are feeling, all of these are electrical signals processed by the brain. For example, the smartphone in front of you. You might think you are looking at the smartphone, but in reality, the light reflected from the smartphone reaches the retina of your eyes, is converted into electrical signals, and then your brain constructs it as the image of the smartphone. Similarly, sound causes vibrations that shake the eardrum, which are sent to the brain as electrical signals and recognized as sound. In other words, the world we perceive is not the objects themselves, but a world of information processed by the brain. From this perspective, it raises the question of what true reality really is. However, if only what our brain perceives is considered reality, do things that the brain does not process exist? In fact, human senses are surprisingly limited. For example, the range of light our eyes can capture, visible light, is only a small part of the entire electromagnetic spectrum. We cannot see infrared or ultraviolet light, nor can we see X-rays or radio waves. However, they certainly do exist. The same goes for hearing. The frequency range that humans can hear is approximately 20 to 20,000 Hz, but dogs and bats can recognize ultrasonic sounds that we cannot hear. In other words, what we perceive as the world is merely the range of information that our brain can process. When you think about it that way, the reality we experience is not an objective material world, but a collection of information. And it is the brain that processes this information. The brain integrates the information received through the 5 senses. It creates the reality in which we exist. However, if the information processed by the brain changes, our reality will also change. For example, hallucinations are an instance where the brain's information processing produces results different from reality. This art piece, which I saw at Toranomon Station on the Tokyo Metro Ginza line, illustrates how the brain's function allows us to perceive space and objects as having 3-dimensional depth. The world humans see is also a result of this. Ultimately, it tells us that what we perceive is a creation of the brain. Additionally, in dreams, we can experience worlds different from reality, yet at that moment, the brain recognizes it as reality. In other words, the world we live in can change infinitely based on the information the brain receives and how it processes it. As quantum mechanics suggests, the smallest unit of the world is not matter, but information. Under certain conditions, they interact with each other at speeds exceeding the speed of light, and physical quantities are not determined before measurement. It is our brain that processes this information and recognizes it as reality. The world we see is not a fixed material world, but a world of information, reconstructed by the brain. Accepting this perspective leads to the question of what reality truly is. It begins to appear completely different. Point 3. The real world is a hologram. In the previous discussion, we explained that the essence of quantum is information, and the world we see is a product of information processed by the brain. Here, I would like to introduce the hypothesis of the holographic principle. Dutch physicist and Nobel laureate Gerard 't Hooft, along with Stanford University's Leonard Susskind, have claimed that all gravitational phenomena occurring in a certain region of 3-dimensional space can be projected onto a screen set at the boundary of that space and understood as phenomena in a 2-dimensional world on the screen. I don't really understand what they're saying, right? To put it in very simple terms, I understand it as saying that this world might be a hologram projected from two-dimensional information drawn on the surface of the universe. This is the holographic principle. To understand it more intuitively, imagine a movie screen. On the screen in a movie theater, two-dimensional images are projected, right? However, when we watch those images, we perceive the characters and landscapes in 3 dimensions. If the entire universe has the same structure as a movie screen, then what we perceive as a 3-dimensional world might actually be the result of 2-dimensional information being projected. The holographic principle suggests the possibility that the 3-dimensional world itself is created by information. And this relates to quantum entanglement. This resonates with the idea suggested by super experiments that what exists there is not reality but information, and the notion that the real world is something the brain creates by processing information. We believe we live in a material world, but it might not be actual matter. Instead, it could be a projection created by information. Point 4. The world is made of information. There was a genius physicist named John Wheeler. He dedicated his life to studying the question of what the essence of the universe is from various angles. In his later years, he reportedly said that he initially thought the essence of the universe was all particles, then considered it to be all fields, and now believes it is all information. The story of a genius who tried to unravel the truths of the visible macro world through physics, and in his later years arrived at the hypothesis that this universe is like a computer and that the true nature of the universe might be information data. Wheeler may have grasped the essence of quantum mechanics. The sense that things exist is so obvious in daily life that there is no room for doubt. But in the quantum world, the idea that reality is an illusion was demonstrated through experiments on quantum entanglement. I was aware of what quantum entanglement indicated as a matter of knowledge, but until now, it was only at the level of, it might be so. It was so far removed from my everyday sense that I couldn't understand it at all. However, coming to this point, the meaning of the idea that what is there is not reality and that the world is made of information is, I finally feel like it's starting to settle in my mind. That said, in terms of physical sensation, I can't believe that what is right in front of me is not reality. It's like not being able to believe that the Earth is orbiting the Sun at a tremendous speed. Yes. Now, moving away from the topic of quantum mechanics, I would like to share my own unique insights gained from the idea that the world is made of information. The idea that the world is made of information might seem grand and complex, but in reality, information is deeply intertwined with our daily lives. This perspective made me feel that various worries and stresses became significantly lighter. This is because we perceive the world in our minds, or in other words, in our brains, based on the information we take in from the outside. As explained so far, information creates our reality. The process by which perception of reality arises from information is constantly happening within us. For example, the eyes catch light, the ears catch sound, and the nose catches scents. The information received by the sensory organs is converted into electrical signals and sent to the brain through the nerves. The brain then interprets and assigns meaning to the information by comparing it with past experiences and memories. For instance, if you recognize a round, red object as an apple, it is because the brain organizes and categorizes the information based on past experiences. However, the meaning received from seeing an apple can differ from person to person. For someone with an apple allergy, it is a dangerous food. For someone who has loved apples since childhood, it is a delicious and nostalgic taste. In this way, we are not simply receiving information from the outside world as it is. We are seeing the world as interpreted by the brain. Isn't it common to think that even though we are looking at the same thing, the way we feel about it is different? For example, even if both person A and person B watch the same movie, person A might say it was very moving, while person B might find it somewhat boring. Why is it that their impressions are completely different even though they watched the same movie? No? This is likely because each person is viewing the movie through their own perspective, shaped by their past experiences and knowledge, acting as a filter in the brain. In other words, we are not all living in exactly the same world. Rather, each of us is living in a separate world constructed within our brains. It seems we can say this. Knowing this way of thinking changes how we view the world. The reality we see is not a constant physical reality that always exists there, but rather a product of information interpreted by the brain. Once you realize this, for example, if someone says something unpleasant to you, you can think, that's how it appears in their world, and not take it too personally. Once you understand that each person lives in a different world, it becomes clear that it's natural for opinions to differ, and it's important to try to understand the other person's perspective. If you change the information you receive and how you interpret it, your view of the world will also change. By incorporating positive information, your mind becomes more proactive, leading to positive actions, and the world will start to appear more positive. So how was it? From the story of the tangled fisherman to the idea that the real world is made up of information. When we apply this to everyday life, it can be said that how we perceive the real world changes based on what kind of information we receive, how our brain processes that information, and what interpretations or meanings we assign to it. From this perspective, we can explore the wisdom of completely changing our perception of the real world through neuroscience and psychology. Philosophy, quantum mechanics, and Buddhist knowledge are borrowed to delve deeply into these topics in the book Simply Life. It's all because of the unconscious. It's a recipe of wisdom that turns a tangled life into a simple line. This book explains how the unconscious creates reality and introduces wisdom to improve your life. If you're interested, please check it out. Thank you for watching until the end this time as well. See you again.